Hey guys, this side Anirudh. I'll be your trainer today. So we have few sessions that we already gone through for BGP. So welcome to the next session. Let's go on.
And guys, so once again we are going to start this BGP, and in previous class I was just teaching you I think BGP attributes. So today once again I will start BGP attributes, right? So as I discussed with you that if we talk about BGP attributes, so we are having mainly two types of BGP attributes. One is known as, tell me, well-known,
Optional.
and another one is optional. Under well-known category, again we are having two different categories.
Mandatory.
Yes, mandatory
Discretion.
and discretionary. Under optional, transitive and non-transitive. So first of all, we have to understand that what is the meaning by BGP attribute, and I hope that all of you have very good understanding of BGP attributes from CCNP itself. Like, I'm not saying that you know everything that how to configure all these things, but at least you have an idea that okay, what is the meaning by BGP attributes in BGP. Like BGP attributes are basically those criteria which are used by BGP for their best path selection, right? Like in BGP actually there is no single metric unlike ESCRP, OSPF and RIP, because in all those routing protocols we were having only and only metric. I mean there was only one characteristic, there was only one character based on which we could manipulate path selection, and it was only and only metric. Like in ESCRP it was metric, in OSPF also it was metric, in RIP also it was metric only. But in BGP you are having various things, various options, right? Multiple options to manipulate your path selection. It's not, BGP is not having only and only metric. It is having some other things as well by which you can manipulate BGP path selection. BGP best path selection. So I hope that you people are getting my point, right? So here in BGP it's not having only single metric, only single you can say character on which based on so here in BGP you are not having only one component on which or based on which this BGP will define its best path selection. There is no single criteria, there is no single thing on which BGP will define its best path, right? So it is having multiple things, multiple you can say components, and based on all those components BGP can define its best path, right? So for best path selection it will be using all these BGP attributes, and we are having various types of BGP attributes available over here, and in different conditions we will be using different attributes in different scenarios. Of course you will be implementing all these attributes. I'll teach you that okay, in this kind of scenario you can use this attribute, in this kind of scenario you can use this attribute, and all these things, fine. So the meaning by well known is, like you know very well that of course for BGP all those attributes will be well known. They can automatically go along with BGP updates. The information of well known attributes can go along with BGP updates automatically. But if you talk about the optional attributes, means that these are optional and by default they will never go by default. Of course they will never go along with your BGP updates, so you have to enable your BGP, you have to enable that feature of BGP, so that BGP will start to carry these attributes information along with BGP updates. So remember that if you are talking about optional BGP attributes, they will never carry, these attributes will never be carried forward along with BGP updates by default. So you have to enable your BGP to carry all these optional attributes information along with BGP update, right? So by default BGP will never send any optional attribute information in its outgoing update. Even though I will not say that it will never set, it will set it, but the thing is, it is optional. It will never go in BGP updates until unless you don't configure it. Try to understand. Optional attribute will never go along with BGP updates, or you can say in outgoing BGP updates unless you don't configure them. So you have to do configuration first, and then after only BGP will start to carry your optional attributes along with BGP updates. So you have to do some configuration, then after only BGP will be responsible, BGP will be able to carry all these attributes information along with BGP updates. Fine. Well known, automatically they will automatically go. I mean, these attributes will be well known. Under well known, again, you are having mandatory and discretionary, and you know very well that what is the meaning by mandatory. I mean, they will always go. I mean, these attributes will always go along with BGP updates. Discretionary, they may go, may not go. May go along with BGP updates, and also they may not go, right? Optional, transitive, optional, transitive. The meaning by transitive attribute is this. Like for an example, if a BGP router receives any update with optional transitive attribute, and in case if that BGP router do not support that attribute, try to understand. If any BGP router receive any update with optional transitive attribute, and in case if that router do not support this attribute, in that case it will not drop your update. It will accept that update and also will forward it to another neighbor, but it will remove that attribute actually. If your router do not support if your router do not support any attribute, then it will remove that and will forward that prefix information to its another neighbor as well. Means it will not discard your update. But in case if your attribute is non-transitive, attribute, in that case, if your router do not support any attribute of incoming updates, of received updates, of course whenever a BGP router will receive any update, it will always check its BGP path attributes as well, right? So whenever it will open all those path attributes, then if it find that okay, it does not support this specific attribute, and if that attribute is non-transitive, then definitely your router will discard all those incoming updates and also will not forward those update information, those prefixes information towards any other neighbor as well. Are you getting my point or not?
Yes.
So here the meaning by transitive is what? If any router receives any BGP update with transitive attribute, and in case if that BGP router do not support that transitive attribute, then also it will accept that BGP update, will install it in its BGP table as well, and also will advertise that update information towards other neighbor as well. But in case if you receive, if BGP router receives any update with non-transitive attributes, and in case if router do not support, in case BGP router do not support that attribute, then definitely your BGP router will discard all those incoming updates and also will not advertise those prefixes information towards any other neighbor as well. That's the meaning by non-transitive. Now we are having some attributes here under well known. Like for an example, this is next hop. Next hop is also kind of attribute, because you must remember that in BGP, next hop must be reachable. If next hop is not reachable in BGP, then definitely BGP will never define that path as a best path. And remember, BGP is a distance vector routing protocol, means that it will advertise only and only best path information towards its neighbor. So in case if there is one prefix in my BGP table, then and if that prefix is not best prefix, if that prefix have not become best for me, it means I'm not going to advertise that prefix information towards any other neighbor as well. Are you getting my point or not? So this time you can see that next hop is mandatory. It will always go along with your BGP updates. That is why it is coming under well known mandatory attribute, and it must be reachable. Then AS path attribute is also there, and you know very well that what is the meaning by AS path. AS path, because you know very well that whenever a prefix will traverse one AS, in that case that AS's information will always be added inside the prefixes AS path list. Inside prefixes AS path list. Like for an example, if a prefix have traversed one AS100, then of course AS100 information would be added inside the AS path list of the prefix of the BGP update, right? Whenever it will across any other AS, then also it will add that AS information as well inside existing AS path list. And remember, ASs will never be replaced by any other AS. They will always be prepended inside existing AS path list. Are you getting my point or not? Apart from it, origin code is also part of mandatory, because origin code will always go along with BGP updates, always. Discretionary, it's kind of local preference. Sometimes you will see that local preference will be part of your BGP path attributes, and sometimes, you will see that sometimes BGP will carry this local preference in its updates, and sometimes it will not carry this local preference information inside its own updates. That is why it will come under well-known discretionary. Under transitive, communities are there. Kind of tagging. Like in OSPF you perform tagging. In same manner you can also perform tagging in BGP as well, which are known as here communities. Under non-transitive you can have med and all these things. Even I will show you that diagram in which you are having all these things. Let me show you. See, origin code comes under well-known mandatory, AS path is well-known mandatory, next hop is well-known mandatory, local preference is well-known discretionary, even atomic aggregate is also part of well-known discretionary. Atomic aggregate is also part of atomic discretionary. Atomic aggregate is also part of well-known discretionary. Here you can see. Now you can ask me that what is the meaning by atomic aggregate. So you will see that this attribute will be in use during aggregation only. Whenever you will perform aggregation in BGP, then only it will start, BGP will start to use this. BGP will start to use this attribute. I will show you during aggregation that okay, now BGP has started to use this attribute here, right? So remember that atomic aggregate comes under well-known discretionary, whereas this aggregator will also be in use after aggregation only. If you haven't configured any aggregation in your network, till that there will not be any uses of atomic. Till that there will not be any uses of aggregator. Aggregator means a router who has performed aggregation. That's the meaning by aggregator. A router who will be responsible to perform aggregation is known as aggregator. So aggregator, this attribute will also be in use whenever you will perform aggregation in your network, and it comes under optional transitive. Community is also part of optional transitive. Whereas MED, multi-exit discriminator, in other words, you can also call it metric. In other words, you can also call it metric, and MED comes under optional non-transitive. Whereas originator ID and cluster list, originator ID and cluster list will also be under optional non-transitive. And the uses of originator ID and cluster list will be during route reflectors only. So if you configure route reflectors in your network, then only it will start to use originator ID and cluster list. And I will teach you that what is the meaning by originator ID, or what is the uses of originator ID and cluster list in BGP. But remember, in BGP, these two attributes will be part of your BGP updates after configuring route reflectors only. So if you do not configure route reflectors in your network, till that there will not be any attribute like originator ID or cluster list. That's why I said that these attributes comes under optional category, because these are optional. Of course, Because if you do not configure route reflectors, it means you will not be able to seek either originator ID or cluster list. So it will be really required for you guys to configure route reflectors before going to see originator ID or cluster list over here. Tell me, is there any problem? So these are the categories of path attributes. Now we have to understand that what is the meaning by all these attributes and in which sequence BGP will define its best path selection, right? So first of all, I'll teach you that in which sequence, how BGP defines its best path, right? So remember that first of all, it checks next hop reachability. First of all, BGP will check its next hop reachability before defining any path as a best path. So in case if next hop is not reachable, then BGP is not gonna to compare any other attribute of that prefix, because in BGP this is primary requirement that next hop must be reachable, and in case if your next hop is not reachable, then definitely BGP will never define that path as a best path. Are you okay with this statement or not? Next is, if next hop is reachable, and let's say this is R1 and this is R2, this is R3. So in case if R1 is getting one prefix coming from R2 as well as R3, and via both neighbors its next hop is reachable, it means now BGP will not be able to define your best path based on next hop address only. So now after next hop address, let's say that via both neighbors its next hop address is reachable. In that case, wait. However, we saw that wait was not part of BGP path attributes. Was that? Tell me, was wait part of BGP path attributes? Of course, no, it was not there. You know why? Because this wait is a Cisco proprietary, and also it has local significance. And remember that if we talk about this wait, there are some rules as well. There are some rules related to wait. First, it has local significance. It means BGP will never carry wait information along with BGP updates. So if you change your wait on one router, then your changes will be effective only for that router only for that router where you have made changes, right? That's why I said that it has local significance. The second thing, for self-advertised prefixes, by default it is for self-advertised prefixes, it is by default 0. Third, for all received prefixes, whether it is received from eBGP neighbor or iBGP neighbor, by default it is, sorry, for self-advertised it was 32768. For all received prefixes, by default it will be 0. So if you are advertising anything, any prefix by yourself, by default its weight will be 32768. Whereas if you are receiving anything from your neighbor, then by default its weight will be 0. Right? Fine. Now remember, higher weight will always preferred. Higher weight will always be preferred. So you must remember all these rules. Now, because here we can see here that R1 is receiving some prefixes coming from R2 as well as R3. It means from both neighbors by default weight will be 0 on R1. On R1 by default via both neighbors its weight will be 0. So it will be same. So it means that BGP will not be able to define your best path based on weight now. So if your selection is not done based on weight, then it will start, it will compare their local preference. Local preference. Now, there is a rule. There are some rules for local preference. BGP will always include local preference attribute in its outgoing BGP updates, but only for IBGP neighbors. So it does not have local significance, right? By default, local preference is 100 for internal prefixes. And what do you mean by internal prefixes? Which are received from IBGP neighbor. Which are received from. So whenever you will receive any prefix from an IBGP neighbor, you will always see that its default local preference will be by default, will be 100. Have you understood it or not? So remember that if you receive any prefix, BGP prefix from your IBGP neighbor, then by default its local preference will be 100. Higher will always preferred. And one more thing, if you are receiving any prefix information, any prefix from your EBGP neighbor, try to understand. If you are receiving anything from your EBGP neighbor, by default its local preference will be nothing. Because if you are receiving any update from your EBGP neighbor, then you will never get any information related to local preference. Even for self-advertised prefix as well, you will not find any local preference. Like for an example, I am a router and I have advertised some prefixes into my BGP table, right? I have advertised some prefixes into my BGP table. So for self-advertised prefixes as well, default local preference will be null, nothing. But remember that if your prefix is internal prefix, which is received from its IBGP neighbor, by default its local preference will be 100. But remember, higher will always be preferred. Whenever your BGP will give any update to its EBGP neighbor, then remember that local preference will never go along with BGP updates. That is why we can say that local preference will never go across the AS. Will never go across the AS. So within an AS, your local preference can play a big role, can play a vital role for best path selection. Right? Now, in this situation, there would be two things. Either R1 is having IBGP neighbors R2 as well as R3, or both of them are EBGP neighbor. So if all of them, I mean R1, R2, R3 are in same AS, then definitely for R1, R2 and R3 both of them will be IBGP neighbor. So let's take an example that, okay, for an example they are IBGP neighbor, right? So if both of them are IBGP neighbor, try to understand, then by default on R1 its local preference will be 100. It will be same. It means that BGP will not be able to define your best path selection based on local preference. And in case if any one of the neighbor is EBGP and one is what? IBGP. From EBGP you will see that it will not receive any local preference, it will be null, and via IBGP neighbor it will receive its local preference as 100. Remember that if you are receiving your local preference as null from one of the neighbor and from another neighbor you are receiving default local preference, in that case also local preference will not take place to define your best path or to perform your BGP path selection. Try to remember, try to memorize. If you are receiving local preference from one neighbor as 100 as default local preference, and from another neighbor you are not receiving anything, any local preference value, like for an example, if any one of the neighbor is EBGP neighbor and another neighbor is what? IBGP neighbor. So in that case, from IBGP neighbor you will receive your local preference as 100, and from EBGP neighbor you will receive your local preference as null. In that case, local preference will never be compared, or local preference will never be able to define your best path. Have you understood it? Have you understood it now? Fine. Local preference, and then after, if local preference is not capable, let's say that both of them are either IBGP neighbor, and might be that one of the neighbor is EBGP and other neighbor is what? IBGP, then also local preference will not be able to define, to select your best path. Of course BGP cannot select its best path based on local preference, but in case if you change it, you can perform. Like in case if both of them are IBGP neighbor, by default it will be 100 via both neighbors, but from, yeah, you can change it. Via one neighbor you can define it 101, so higher will always be preferred, but this time of course it's not gonna to define its best path based on local preference. Next, self-advertised. What does it mean? Let's say there are two routers R1 and R2. You advertise one prefix 10.1.1.0/24 on R1, and same prefix you advertise on R2 as well, 10.1.2.10.1.1.0/24. Now R1 will be having this prefix in its BGP table as self-advertised, as well as it will receive the same prefix from R2. So first of all it will compare their weight. Based on weight it will define its best path. After weight it will compare their local preference, and in case if local preference is also common, then it will define its best path as self-advertised. So for R1 its self-advertised will be best path. But what if you are receiving prefix from your neighbors only? You are not advertising that prefix by yourself. Will this thing take place for BGP best path selection? In that case, if you are receiving your prefix from your neighbors, you are not advertising it by yourself. See, this self-advertise, this is not attribute actually, because this information will never be carried forward along with BGP updates, right? But you must remember that it will also take place in BGP best path selection. Try to understand it, and if you are having any problem, please let me know. Tell me, any problem in it? In self-advertised, see, me, I'm advertising one prefix from my end, usual is also advertising the same prefix towards me. Now I will be having two entries for the same prefix in my BGP table. One which I advertise by myself, one which is received from usual. So by default I will prefer self-advertised. That's the main one. Fine. But in this case, like R1 is receiving prefixes from R2 as well as R3, it is not advertised by R1 itself, right? So of course it's not going to take place. Now AS path attribute will take place. Now AS path have came into the picture. This attribute, AS path attribute. It means if it receiving any prefix coming from neighbor R2 as well as it is receiving prefix coming from neighbor R3, it will compare their AS path list. It will check, it will count total number of ASs available in their AS path list. AS path list can have maximum up to 64 ASs. Or what is that? There is a limitation, I think. Inside AS path list, I mean like BGP can have maximum 64 ASs inside its AS path list. It's not like that you can have unlimited number of ASs. However, might be that it can vary according to iOS, but I found it somewhere that maximum 64 ASs can be there inside the AS path list. So this time, let's say R1 is receiving a prefix coming from R2 as well as R3. Via both neighbors, it will calculate total number of ASs available inside the AS path list of received prefixes. Are you getting my point or not? So it will define that path as best path, which is providing destination network after crossing less number of ASs. Right? So a prefix which is having less number of ASs available inside its AS path list will be best path now. But let's assume via both neighbors it has to across same number of ASs. So of course, if R1 has to cross same number of ASs to reach destination prefix, then definitely based on AS path attribute, BGP will not be able to define its best path. Are you getting my point or not? Try to understand. In case, oh my god, I have to draw everything, huh? This is R1, R2, R3, R4. Let's say you are using AS40, AS20, AS30, and this is what? AS10. So there is a prefix 40.1.1. It will come via R2, it will come via R3 as well. So via R2 it has to across what? 20 and 40, whereas via R3 it has to across 30 and 40. Via both neighbors it has to across 2 ASs. It means that now you will not be able, or BGP will not be able to define its best path based on AS path attribute, or it will not be possible for BGP to select its best path based on AS path attribute. And if it is not possible to select your best path based on AS path attribute, the next attribute will take place, and which is origin code. So now origin code will take place. If you talk about the origin code, we are having multiple origin codes available over here. Like you must understand the meaning by origin code. In BGP, we are having 3 different types of origin codes. First is I, which means IGP. Then E means EGP. Question mark, incomplete. IGP, I mean in origin code only, the meaning by IGP is that your BGP prefix is, it's all about the BGP actually. Here in origin code only, in the example of origin code only, meaning by IGP is BGP. And this is the only case throughout the BGP, where meaning by IGP, I mean throughout the routing protocols, where meaning by IGP is what? BGP. But once again, you must remember, if condition is there that your prefix must be advertised into BGP with using network command. So if you are advertising anything into BGP with using network command, network 100.1.1.0, because in BGP, in most of the cases, you will be using network command to advertise your prefix. So if you are advertising anything into BGP with using network command, by default, its origin code will be I. By default, its origin code will be I. Are you getting my point or not? So here meaning by IGP is what? BGP, where you have advertised your prefixes with using network command. E means EGP, and this EGP is that protocol which came before BGP. So I don't think so that you will ever get this EGP origin code now, because EGP is not running anywhere in the network nowadays. That's why I said that you will never get this EGP now. Finally, it's question mark, which is also known as incomplete, and it is also redistributed route. I mean, if you redistribute anything into BGP, by default its origin code will go as question mark. And remember, I is always preferred over E. E will always be preferred over question mark. I will always preferred over E, and E will always preferred over question mark. Fine. Now in this case, let's say that your origin code is also common. Let's say you advertise that prefix onto R2 as well as R3. I mean, on source you advertise that prefix with using network command. So this time R1 is receiving this prefix coming from R2 as well as R3 with origin code I. So from both neighbors, its origin code is common now. So it means that based on origin code also, now it will not be possible for R1 to define its best path. I mean, BGP will not be able to select best path based on origin code as well, if it is receiving same origin code from both neighbors. But you can manipulate it. But this time we are not talking about the manipulation, right? We are just talking that sequence. I mean, we are talking about that sequence in which BGP defines its best path. So after going through the origin code, if origin code is also common, then it will check MED, multi-exit discriminator, and in other words, you can also call it metric. Fine. Remember, MED by default will be 0. By default, metric will always be 0. But remember that lower will always be preferred. And this metric, this MED, is same as that metric which we were having during ICPs like RAP, ICRP, and OSPF. Because if you redistribute any routing protocol into BGP like EICRP, OSPF, or RAP, their metric will go along with BGP updates in the form of MED. That is why in BGP also lower metric will always preferred over higher one. कई काम से guys, so remember lower med will always be preferred over higher, but by default it is 0. It means again for BGP its metric will be 0 via both neighbors. So again based on med, BGP will not be able to define its best path. Now if best path selection is not done based on med as well, then it will start to compare external over internal. I mean external will always preferred over internal. Let's say that you are having this kind of diagram now. This is R1, R2, and this is what? R3. Let's assume that for R1, R2 is IBGP neighbor, whereas for R1, R3 is what? EBGP neighbor. Let's say for R1, R2 is IBGP neighbor, whereas R3 is EBGP neighbor. Now R1 is receiving same prefix coming from IBGP neighbor, and also it is receiving same prefix coming from EBGP neighbor. Remember, if all attributes before than external over internal, I mean external preferred over internal, all other attributes are common, then external will always preferred over internal. Means a route learnt from EBGP neighbor will always preferred over route learnt from IBGP neighbor. Have you understood it or not? But remember, before that all attributes must be same. If your election is already done based on weight, then of course this external internal is not going to take place. Even local preference will not take place if your election is already done based on weight attribute. If your election is done based on local preference, then AS path attribute will never take place. Yes?
So, AB value तो वैसे different होता है कि
Of course.
तो AB value अगर external को
That is why we are saying that external will always be preferred over internal.
इसके बाद वो AB
Exactly,
करता है।
exactly, exactly, exactly.
अगर बाई चांस किसी रूट का मतलब इन प्रेफरेंसेस में पहले वाले प्रेफरेंसेस में इंटरनल वाला प्रेफर होगा फिर तो एडी
Obviously बात है.
उस टाइम
That's why we don't talk too much about AD values in BGP. That is the reason, so that we do not talk too much about AD values in BGP, because now AD value is going to take place here. Understand? Then after it, if now it is also possible that both of them are IBGP or both of them are EBGP. So either via both neighbors it will receive internal prefix, or via both neighbors it will receive external prefix. Let's move back again on this page now. If your election is not done based on external internal as well, the next attribute will be IGP cost to reach next hop. And this IGP cost is that cost like EICRP and OSP. Sometimes what do? We can also configure IGPs in the background of BGP. Sometimes we can also configure IGPs in the background of BGP. So if you are using IGPs along with BGP, and then after BGP can also compare the IGP cost to reach next hop address. I will teach you later on that what is the meaning of it. But remember, this attribute will take place in case if you have configured IGPs along with BGP. I will teach you this attribute during practicals only, not before that, right? Then next, let's say there is no IGP configured in the background of BGP. The next will be oldest path, but condition is there for EBGP neighbors only. For EBGP neighbors only. What does it mean? That if both of them are EBGP neighbor, then let's say that R1 received this prefix 10.1.1.1.0/24 from R2 first, and then after some time it also started to receive same prefix coming from 10. Via R3 as well, and both of them are eBGP neighbor. Then for R1 its best path will always be via R2 only, because first of all it received this prefix from R2, from eBGP neighbor R2. But remember, in this condition both neighbors must be eBGP neighbor. So if you are receiving same prefix coming from two different eBGP neighbors, then oldest path will always be preferred, but it will be compared in case of eBGP neighbors only. If both neighbors are eBGP neighbors, then it will compare their router IDs of neighbor, and lower will always be preferred. So I will define lower router IDs of neighbor. Lower router ID of neighbor, not router ID actually. Lower router ID of neighbor. So of course if you are having two different neighbors, they must have different router IDs. So a neighbor which is having lower router ID, see, this router ID by default will not take place in case of eBGP neighbors. It will take place only for iBGP neighbor. So let's say in this condition now both of them are iBGP neighbor, because if both of them are eBGP neighbor, then oldest path will take place, right? Oldest path will take place. But in case if both of them are iBGP neighbor, then oldest path will not take place. So in that case it will start to compare their router ID. So for R1 the best path will be via that neighbor who is having lower router ID. Let's say R2 is having lower router ID than R3, then for R1 its best path will become via R2. But it is also possible that you can have same router IDs on your neighbor as well. It is also possible to have same router IDs on both neighbors. So in which condition you can have, like this is R1 and this is what, R2. You are having two separate connections in between these two routers now, and you have configured neighborship with using both connections. So for R1 now on both neighbors, because there will be two neighbors now, but on both neighbors router ID will remain same. Now lower neighbor address, finally lower neighbor address will take place. Lower neighbor address will take place, will be best. And all these things, oldest path and all these things are known as tiebreakers. Oldest path, lower router ID, it is lower router ID of the neighbor, then lower neighbor address, all these things are known as tiebreakers. Right? So if all attributes are common, then finally tiebreakers will take place, and tiebreakers will define your best path in BGP. Fine. By default BGP do not support equal cost load balancing, because by default maximum path is configured as 1. By default in BGP maximum path is configured as 1, but BGP also supports equal cost load balancing. You must remember that BGP also supports equal cost load balancing. But remember that up to IGP cost to reach next hop from here, see, from here, here and here, up to here, IGP cost to reach next hop, all these attributes must be same. Then only BGP can perform equal cost load balancing. All attributes up to here, from next hop, weight, local preference, self advertised is path, origin code, MAD, external, internal ICP cost to reach next hop. So all these attributes must be same. If any one of the attribute out from all these attributes is not same, then BGP will not be able to perform equal cost load balancing. In that case, it will define its best path only. It will install only best path inside its own routing table. Remember, BGP will install only and only best route information in its routing table. So to perform equal cost load balancing in BGP, all attributes up to ICP cost to reach next hop must be same. And remember, BGP will always compare these attributes in this sequence only. There is no other sequence. Like if BGP path selection has already done based on local preference, it means it is not gonna to it is not gonna to compare there is path attribute origin code or MED, because your election is already done based on local preference. Understood or not? Tell me, Piyush. Now, the biggest question over here is where to use MED, where to use AS path. So along with practicals, I will teach you that in these conditions, if you are having this type of conditions, then you should use AS path. In these types of conditions, you should use weight. In these types of conditions, you should use local preference, right? So I'll be discussing it later on, but I hope that you have understood now all these, the path selection process of BGP. Fine. Now, there are some loop avoidance techniques in BGP. Loop avoidance mechanism. So now remember, in BGP there is no split horizon, nothing like that. There is nothing like a split horizon. Fine. But in case if you are having like R1, R2 and R3, prefix is advertised by R1, R1 can give it to R2, R2 can give it to R3, and R3 can give it back to R1. And due to this only there can be routing. So how will it be possible for BGP to prevent your network from routing loops? So there must be some mechanism to do it. So there are basically two different mechanisms which are used by BGP to prevent itself from routing loops. The very first thing is BGP will always discard all those updates which are carrying its on AS. Try to understand. BGP will always discard all those updates which are carrying its on AS inside there. AS path list. Right? Are you getting my point or not? Now, try to understand, please. This is R1, this is R2, this is R3. Let's say this R1 is using AS10, this R2 is using AS 20 and this R3 is using once again, let's say AS 10. So if R1 has advertised anything into BGP now, let's say this 10.1.0/24, R1 will give it to R2 now, and it will give this update to R2 that if you want to reach 10.1.0/24, then you have to cross AS 10. It will accept it because it is running AS 20. It will not found its own AS. Try to understand, it will not find its own AS inside the AS path list of received BGP updates. Fine. Now further, R2 will also advertise this prefix information towards R3 as well, that if you want to reach 10.1.1.0/24, you have to cross first of all 20 and then 10. So this time when R3 will open its AS path list of these received updates, it will find its own AS. It will find its own AS inside AS path list of received BGP updates. So it is not gonna to accept it, it will discard it. Simple. It means now R1 cannot have routes coming from R3 and R3 cannot have routes coming from R1. That is why now there will not be any loop now. See, let's say this is R1, R2, this is R3. This is using AS10. AS30. R1, let's say R1 is not advertising this prefix towards R3, but it is advertising it towards R2. So it will give this R2 that if you want to reach 10.1.0, then you have to cross AS. Tell me, AS 10. AS 10 will be there inside the AS path list. Then R2 can advertise it in the direction of R3 that if you want to reach 10.1.1.0/24, then you have to cross AS 20 and 10. So it will also accept it. Then R3 can advertise it back towards R1. So it will say that okay, if you want to reach 10.1.1.0/24, then you have to cross 30, 20 and then 10. So whenever this R1 will open this AS path list, it will find its own AS. So will this R1 ever accept this update over here? No, it will simply discard it here. That is why there will not be any routing loop. But there is a small problem now. The problem is fine. The problem is, let's say this is R1, this is R2, this is R3. Let's say all of them are in same AS now. All of them are IBGP neighbor, right? So there is a prefix behind R1, 10.1.1.0/24. R1 will advertise this prefix that if you want to reach it, then you have to cross AS. Will R2 accept it? Will R2 accept it? It will discard it. But remember, there are some rules in BGP that if you are giving an update to your eBGP neighbor, try to understand, if you are giving an update to your IBGP neighbor, IBGP, right? Then you will never prepend your AS path information. You will never prepend your AS path information in AS path list. if you are giving an update to your IBGP neighbor, you will never prepend your own AS into AS path list. Means that, because for R1, R2 is this time IBGP neighbor. So this time when R1 will advertise this prefix towards R2, it will not add its own AS information into outgoing BGP updates. Inside there is path list especially, right? So this time R1 will not add AS 100 inside AS path list. What does it mean now? R2 will receive this update without AS 100. It means R2 will not find its own AS in received updates. Are you getting my point or not? Remember that in BGP, AS path prependation will be done when you are giving an update to your eBGP neighbor only, not to IBGP. Because if you are prepending your own AS in case of IBGP neighbor as well, in that case, what can happen that even your IBGP neighbor will not be able to accept your prefixes. That is why this rule is there in BGP, that if you are giving an update to your IBGP neighbor, then it will never prepend its own AS information onto outgoing updates, right? And if you are giving an update to your eBGP neighbor, then definitely you have to prepend your AS information onto outgoing BGP updates. Understood or not? So that rule exists here in BGP. Fine. So this time, of course, when R1 will advertise this prefix 10.1.1.0 in the direction of R2, because R2 is working as an IBGP neighbor, right? So R1 is not going to prepend its own AS information onto this prefix. So when R2 will receive this prefix coming from R1, will R2 receive this prefix with its own AS? No. So that is why this R2 will accept this prefix this time without any problem, and R2 will install that prefix into its routing table as well. I mean, first of all, R2 will install this prefix inside its BGP table, and then from BGP table it will install that path, that prefix into its routing table. Have you understood it, Rizvi? Is it okay for you? Great. Now, because it is not adding, because for R2 also, for R2, R3 is also working as IBGP neighbor. So R2 can advertise that prefix towards R3, and it will also not add its own AS information, so R3 will accept it, and then R3 can send it back to R1, and R1 will also accept it this time, because R1 will not find its own AS info. So again, there can be a routing loop, but to prevent your network from this type of routing loop, again in BGP we are having a rule which is known as IBGP rule, So another rule also exists here to prevent your network from routing loops here in BGP, which is known as IBGP rule. And what is the meaning by IBGP rule over here? That if you receive anything from your one IBGP neighbor, then you will never advertise it towards another IBGP neighbor. If a BGP router receives anything from one of the IBGP neighbor, then it will never advertise that information toward any other IBGP neighbor. This is called IBGP rule. What does it mean? That in case, if you are having this diagram now, R1, R2, this is R3. Now R1 is having one prefix 10.1.1.0/24, and if let's say that all of them are in same AS, so R1 will advertise this information, this prefix information towards R2, distance.1.1.0/24, right? Are you getting my point or not? So R1 will advertise this information towards R2 now, and if R2, because for R2, R2 have received it from one of the IBGP neighbor. So R2 received it from IBGP neighbor R1. Will it be possible for R2 to advertise it towards R3 now? And if R3 do not receive it from R2, will it be possible for R3 to send it back towards R1? Tell me. Try to understand. This time, will it be possible for R2 to advertise this information which was received from R1 towards R3? This time R2 will not advertise all that information which came from R1 in the direction of R3. In same manner, if R3 receives anything from R1, then R3 is not going to advertise it towards R2. That is why in IBGP there is a rule that your neighborship, IBGP peering must be in fully matched way. Your IBGP neighborship must be in fully matched way. Because the thing is, let's say this is R1, this is R2, they are connected in a sequence and all of them are having IBGP neighborship. Now will it be really possible for R1 and R3 to communicate with each other? Will R2 exchange information in between R1 and R3? So in this case now it will also be mandatory to form IBGP peering in between R1 and R3 as well. It means your IBGP peering must be in fully matched way, and that is why what do we do actually, that we will, because in BGP we can configure BGP peering in between two directly connected devices as well as indirectly connected. The only thing which is required in BGP that your neighbor must be reachable. So what can we do? We can create one loopback on each router, and then we can configure either EIGRP or OSPF between them, and then we can configure BGP peering in between R1 and R2 with using their loopbacks. In between R1 and R3 also with using their loopbacks. In between R2 and R3 as well with using their loopbacks. There will not be any problem. Even though you do not have physical fully matched connectivity, but still you can form BGP peering in fully matched way. Hello, you do not have fully matched physical connectivity here in your diagram, but still you can form fully matched BGP peering. Because in BGP you can also form BGP peering in between two indirectly connected devices as well. Have you understood it or not? Hello. That is why this rule is there that you must have IBGP peering in fully matched way. Otherwise, devices will not, your devices will not be able to access routes with each other. And that's a problem. Here there cannot be any loop. Let's say I'm not having any IGP configured in the background of BGP here. So will it be possible now to form neighborship in between R1 and R3? That's the problem. That's the problem now. To solve this problem, here we are having route reflectors. We can use the concept of route reflectors over here.
So ये IBGP रूल कोई कई बुक्स में BGP splitter ऐसे भी बोलते हैं?
Of course, you can also use this keyword as well. But this is technically known as IBGP rule. Have you understood it now completely? Fine. Now to solve this problem, like sometimes what happens, it is not possible for you to form BGP peering in fully matched way, and also total number of neighborship will be too much. To solve this problem, you can configure route reflectors. However, in this diagram you can see that R1 and R3 will, by default R1 and R3 will not be able to exchange their prefixes with each other, and also if we exchange their routes with each other, then also there will not be any routing loop. So now if we want that R1 and R3 they must be able to exchange their prefixes with each other, here we can use the concept of route reflector. See, I will teach you route reflector in more and more details, but for now just try to understand this route reflector in terms of configuration only. because I will be using route reflectors during configuration, but there will be a topic in BGP itself of route reflector. At that moment, I will teach you that what happens or what is happening in the background of route reflectors. How can we break this rule of IBGP? I mean, how can we break this IBGP rule with the help of route reflectors? Right, so I will be discussing it during route reflector only, that during that topic only, but this time I'm just giving you the basic idea of route reflectors. So if you are having this type of network, then definitely R2 is not going to exchange routes in between R1 and R3. To solve this problem, because definitely you will require to solve this problem, and you can solve this problem by using here route reflectors. In route, when you talk about the route reflectors, here we are having mainly three things. One is known as route reflector, which is also known as server itself. One is known as non-client and one is known as client. NC means non-client. There are three things in route reflectors: RR, NC, client. So let's say on R2 I configured that neighbor R1 is route reflector client. Route reflector client. Just after doing this configuration on R2, now R2 will automatically become RR, because you configured R1 as client, so R1 will become now client for R2 only. However, R1 will never come to know that it itself is working as client for this server. R1 will never come to know about this information, but for R2, of course, R1 will be working as client. Whereas because you didn't configure any command for R3, so it will be now non-client, and R2 will keep on to do work as route reflector. On that router, wherever you will configure this neighbor route reflector client command, that specific router will always become route reflector, or you can also call it server. And now remember, server can exchange routes between client and client, between client and non-client as well, but between non-client to non-client it cannot. Between two non-clients, route reflector cannot reflect routes, but between client non-client, between client client, of course route reflector can reflect routes. Let's continue it once again. See, we are having all these things in BGP. Apart from it, you must also have the information about the basic rules of BGP. I think it's not required anymore. So here there is a rule of next hop address as well. There is a rule of next hop address as well, and it's very simple, that whenever you will give an update to your eBGP neighbor, whenever you will give an update to you will advertise your updates after modifying their next hop addresses. You will advertise your updates after modifying next hop addresses in this way. I mean, same as ESGRP and OSPF do. Like here, this is R1, R2, R3, and this is what? R4. On R1, you are having 10.1.1.0/24. It's in AS 10, it's in AS 20, it's in AS 30, and it is in AS 14. Now this 10.1.0/24 I will advertise it on R1, and let's see here you are using 12.1.1.2, 23.1.1.2, and here .3, and here 34.1.1.3, and here .4. Fine. Now whenever this prefix will come to R2, will come on R2, it will come as like this: 10.1.0/24 via, tell me, 12.1.1. Fine. When R2 will give this update to R3, it will say that okay, if you want to reach 10.1.0/24, you can reach it. Even here AS information will also be there, that you can reach it after crossing AS 10. when R2 will give this information to R3, it will say that you can reach it via 23.1.1.2 and you have to cross AS 20 and 10. Then R3 will further give this information to R4 that if you want to reach 10.1.1.0/24, then your next stop you can reach it via 34.1.1.3 and you have to cross ASs such as 30, 20 and 10. Fine. This is the default rule only for eBGP, and it was same thing was happening in case of EICRP, OSPF, RAPE and all. Fine. But if you are having iBGP neighbor, like for an example, if here they are eBGP neighbor, but let's say here you are using AS20 and also here you are using AS20, then you will see here it will be iBGP neighbor and it will also be iBGP neighbor. So here next hop will remain as 12.1.2 and here also next hop address will remain as 12.1.2. So there is a simple rule. Whenever you will give an update to your iBGP neighbor, you will give it without modifying its next hop address, because R2 received it from eBGP neighbor but is giving it to iBGP neighbor. So R2 is advertising these prefixes coming from R1 towards R3 without modifying their next hop address, because there is a simple rule that whenever you will advertise, you will give any update to your iBGP neighbor, you will not modify their next hop address, and by default, by default BGP will not modify its next hop address. And in near future I will teach you that why is it required or how is it really beneficiary for us, how it is beneficiary for us. Of course it is beneficiary for us. That is why we are having this rule for iBGP that you will not update your next hop address. There are some conditions, there are some situations in which of course it will give us some advantages. I'll tell you all those things, right? But right now you can see here that whenever routers, BGP is giving an update to its iBGP neighbor, it is not modifying their next hop addresses. Are you getting my point? Fine. And this time AS will be only 10. It will only be 10 because you are using only two ASs here, AS10 and 20 only. But remember that whenever you will give an update to your eBGP neighbor, you will always give that update to your eBGP neighbor after modifying its next hop address. Let's say you advertise something from R4 40.1.1.0, it will give it to R3, it will give it to R2, and on R2 it will receive it in this manner. 40.1.0/24 is reachable via 34.1.1.4. But whenever R2 will give this update to R1, now it will say that you can reach 40.1.0/24 via 12.1.1. So there is very simple rule that if you are giving an update to your iBGP neighbor, you will never modify its next hop address, and if you are giving an update to your eBGP neighbor, you will always advertise those updates towards eBGP neighbor after modifying next hop address. Any problem? Piyush, are you okay with it? Fine. After it, now the question is that how can you modify their next hop address? So there are two things. One is next hop self command, another one is what? Route map. So you can modify next hop addresses of your prefixes by using two different methods. One is next hop self, but remember next hop self can be configured only on edge router. Like here, if R1 is giving distance prefix to R2, then R2 was giving it to R3 without modifying its next hop address. So on R2 you could configure this command that neighbor R3 next hop self. So what does it mean? That I'm instructing R2 that before advertising update to R3, modify its next hop address. But remember, this command can be configured only on edge router. I mean only on that router who is receiving prefixes coming from ABGP neighbor and giving them to IBGP neighbor. So this time R2 is the only router who is receiving prefixes coming from ABGP neighbor and giving it to IBGP neighbor R3. So only on R2 we can configure this next hop self command for R3 on R2 only. You cannot configure this next hop self command on R3 or on R4. Any problem? Fine. Now let's perform some basic practicals of BGP. Basic practicals only, right? I'll teach you each and everything so that we have to start it from very basic actually. I'll be using very simple diagram over here. This is, let's say, R1. This is, let's say, R2, and this is what? R3, and this is R4. I can take R5 as well. Right? And then let's start it. So I have configured all these devices according to this diagram. And now, first of all, I'll teach you that how to configure BGP peering, right? In between R1 and R2. I will not configure BGP on any other router. And let's configure BGP peering with using same AS. So I'll be using AS 100 on R1. In same manner, I will be using AS 200 on, sorry, here on R2 as well, I will be using AS 100 itself, right? So let's start it from R1. It's very simple. See, router BGP 100, right? And one more thing, on a single router you cannot run more than one process. Sorry, router BGP 200. What is it saying? That it is already running AS 100. So if you don't know about your running AS, then of course you can type any AS and then it will show you that this is the running AS. And say once again router BGP 100. So if you want to configure AS 200 now on this router, you have to remove the existing one and then after you can run another AS, right? So router BGP 100, and then after remember that BGP will never get enabled on two interfaces. It will always run globally, right? So do one thing, say neighbor 12.1.2 and remote AS is what? Same AS, right? 100. And now you see debug IP BGP, and also you can start capturing here and move again back on R1 and you see show IP BGP summary. This time it is in active state. You know why? Because on far end, on another end, I have not enabled this BGP, and this router, this R1 will keep on to send, it will keep on to try to form TCP session. It will send SYN message, see, it will send it very soon. See, it sends SYN, but neighbor router has sent reset message back. Because right now neighbor is not listening on this port number 179. That is why this reset message has been transmitted back from R2 to R1, right? Reset, see. Now do one thing, move back again on R2 now, and on R2 also you say you configure this AS 100 and then say neighbor 12.1.1 remote AS is what? 100, and now you see that everything will be in proper manner. Next, now it will take some time, right? Because R1 has already initialized this TCP connection. See, it's done now. It is done. Neighborship have came up. See, SYN message, SYN plus ACK, and finally ACK. And this SYN message does not contain anything apart from, say, TCP session. See, it's containing only SYN, window size, and all these things are there. And then you can also move back on R1. You see, neighborship have came up. So first of all, neighborship moved from you see active to open send. Then from open send to open confirm, and then from open confirm to established. So finally, show IP BGP summary. This is the command by which you can check whether neighborship is up or down. Show IP BGP summary. This is in the output of this command. You will see that version 4 is running, and this is the remote AS actually, and this is remote neighbor IP address. Message received from neighbor, message sent to this neighbor, then input queue, output queue for this in respective of in perspective of this neighbor. Up or down, it is up from last 52 seconds. State, if your neighborship is stuck in any state, then it will show you here that state. But if your neighbor is in established state, it will never show you any state under state option. And prefix received, has it received any single prefix from its neighbor? That's why prefix received is what? 0. Apart from this command, show IP BGP summary, you are also having this command as well here, which is show IP BGP neighbor. You can also use this command, show IP BGP neighbors, and in this neighbor command you can see BGP neighbor is what? 12.1.2. Whereas the router ID of remote router ID is what? 2.2.2. However, I didn't configure the router ID of R2, but it picked its highest loopback interface IP address as router ID, right? Version is running 4, and this internal link is showing you that it is an IBGP neighbor. This internal link is showing you that this is an IBGP neighbor, and state is established, and it is up from last 1 minute and 43 seconds, and hold down timer is by default 180 seconds, whereas keep alive interval is by default 60 seconds. It has sent one open message, it have received one open message. However, it have sent 3 keep alive and also have received 3 keep alive from this neighbor, and total number of messages sent is 4 and also received is 4. Then apart from it, it is also having some capabilities which are by default there, like route refresh and address family IPv4 unicast. So route refresh means you can ask to your neighbor to refresh your routes to retransmit updates, right? By using command clear IP BGP star in or out. You remember that you use those commands during BGP, and if you have not used those commands during CCNP, don't worry about that. Here I will be using all those commands, and this feature route refresh capability came in version 4 only. And one more thing, another capability, neighbor capabilities is also there, address family IP v4 unicast. This address family is by default there in BGP. That is why neighborship have came up automatically. Previously in older versions of BGP, it was necessary to activate your neighbor. It was mandatory to activate your neighbor, because by default, this default address family IPv4 unicast was not configured. But nowadays in BGP, this default address family for IPv4 unicast is automatically configured. That is why neighborship have came up even without activating your neighbor. Even I can prove it. How will I prove it actually? Do show, see, apart from it, check some other things as well. Show IPBGP neighbors. Let me show you. See, prefixes current, sent, received, total prefixes sent, received, implicit withdrawn, explicit withdrawn, used as best path, how many prefixes are there, and local policy denied prefixes, all these things. Number of NLRIs in the update sent, maximum and minimum. And then apart from it, what is it showing you? That localhost is 12.1.1, local TCP port number we took as 45374, which is random port number, and foreign host is 12.1.1.2, remote host, and remote port number is what? 179. Biggest source will always be random port number, whereas destination port number will always be a well-known port number. source port number, I mean whenever TCP session will be initiated, source port number will always be a random port number, whereas destination port number will always be a well-known port number. So this time this TCP session is what? Active, and that's fine. Now let's do one thing, say no router BGP 100 from R1, move on R2 as well, say no router BGP 100. Fine. I removed BGP S100 from both routers. And once again I will be configuring IBGP neighborship between these two routers now. I'll say router BGP 100. Now I will remove that default address family. No BGP default IPv4, and then I will define my neighbor 12.1. Remote AS is what? In same manner I will move on R2, router BGP 100, no BGP default IPv4 unicast, and then say neighbor 12.1.1, remote AS is what? So IP BGP summary. Even it have not initialized BGP process, because this time you have removed that default address family. Nothing, because you removed default. So if you do not use default address family, in that case you have to activate your neighbor manually. Apart from, I mean, you have to activate neighbor after defining your neighbor and remote AS, right? So router BGP 100, create address family by yourself now, and then neighbor 12.1.2, and then say activate. In same manner, move on R2, router BGP, address family IP, something like unicast, and then neighbor, and then say now neighborship must come up. So IP BGP summary, check it out. Your neighborship is still inactive state, but finally you will see that neighborship will come up, will move into established state. Just wait for a moment. So in older iOS's, it was mandatory to activate, I mean in older version of BGP actually, in older versions of BGP it was mandatory for us to activate your neighbor manually. I mean it was mandatory for us to create address families and to activate your neighbor. But this time in version 4, BGP is having default address family for IPv4 unicast. That is why even after configuring neighbor and remote AS command, your neighborship will come up without activating your neighbor. But if you have removed default address family from your BGP from both ends, then it will be mandatory for you guys to activate your neighbor, just like we performed here. Even though in live networks it is always recommended to disable your default address family and then activate your neighbor explicitly, so that neighborship will come up with only those neighbors to whom we have activated. Is not it? Neighborship will come up, BGP will form neighborship with only those routers which have been activated by you in BGP. Fine. This is that how can we configure IBGP peering. Now let's configure eBGP peering. So do one thing, say no router BGP 100, and on R2 as well, say no router BGP 100. Fine. Move back again on R1, say router BGP 100 and neighbor 12.1.2. Remote AS is what? 200 this time. Then go back to R2, router BGP 200 and then neighbor 12.1.1. Remote AS is what? And now your neighborship in between these two routers must come up. See, remote AS is what? 200 on hour, right? and this time check show IP BGP neighbors. Neighbor is this, remote AS is 200 and external link means it is an eBGP neighbor. Fine, and that's fine. One more thing that you must understand here, default minimum time between advertisement runs is, and this rule is only for eBGP neighbor, not for iBGP neighbor. What does it mean? That the minimum time interval in between two consecutive update for eBGP neighbor will be 30 seconds. Let's say that if you have advertised any information towards your eBGP neighbor, now next advertisement would be just after 30. Next advertisement can be after 30 seconds only, not before that. This is the minimum time interval in between two consecutive updates only for eBGP neighbors. That's why we says that BGP converge slowly. Because if change, let's say that you have advertised some information to your eBGP and then just after 5 seconds another change was occurred. Now that change will never be propagated before than 25 seconds. So your router has to wait for next 25 seconds and then after those changes will be propagated towards your eBGP neighbor. So remember, the minimum time interval in between two consecutive advertisement in between two consecutive updates for eBGP neighbor is 30 seconds. This is for consistency, because if changes are occurring frequently on frequent basis, then definitely BGP table will get changed frequently, right? And if your BGP table is getting changed frequently, it means your CPU utilization of your device will be higher. Understood or not? Tell me if you are having any problem, please let me know. So I hope that you people have understood the meaning by default minimum time between advertisement runs is 30 seconds. And then after, I also wanted to show you some other things as well. See, of course, keep alive and updates, nothing, no update, because we have not advertised anything into the BGP yet, right? Route refresh, we have not asked our neighbors to refresh our routes, right? So that's why nothing. Apart from it, I wanted to show you that by default its outgoing TTL is what? 1, right? For eBGP. Remember, for eBGP by default outgoing TTL is 1, whereas for iBGP by default outgoing TTL is what? 255. For iBGP outgoing TTL is 255, whereas for eBGP by default outgoing TTL is 1. Cool. Here I configured eBGP peering in between R1 and R2. That's true that we can configure it, right? Apart from it, now I'll do configuration in between R1 and R2 with using BGP itself, but this time I'll configure BGP peering with using their loopback interfaces. So move on R1 and say no router BGP 100. On R2 also I'll say no router BGP 200. I'll remove BGP from both of them. After removing BGP from these two routers, R1 as well as R2, this time because I wanted to configure BGP peering in between R1 and R2 with using their loopback interfaces. So at least reachability must be there, right? Reachability must be there. So you do one thing, go to R1 and configure a route so that R1 can reach the loopback of R2. And this is what? Default route. See? You can reach 2.2.2 from here. Move on R1, sorry on R2, because it does not have route to reach 11111. So do one thing, say and next hop will be stripe route. It have now this default route, so you can reach even when source is loopback, reachability is there now, right? So R1 can reach R2 very easily without any problem. Ping 22222 when source is it's on. So this time I'll configure BGP peering with using their loopback addresses only. So router BGP, sorry, remote AS, let's say it is also using, and then in source. So what is the meaning by this update source command? by default in source, because whenever it will send SYN message, it has to put source address as well. So by default, it will pick its source address as its exit interface's IP address, right? But here I wanted to form BGP peering with using their loopback addresses only. So in source also, I wanted to put my loopback interface. So to modify your source of BGP neighborship, you can use update source command. Now let's move on. R2 router BGP remote ASs. Fine. So now neighborship must come up, right? Show IP BGP summary. It is in active state. We have to do wait for 1 minute, 2 minutes, 3 minutes for whole day. Neighborship will not come up. Why? Neighborship will not come up. The thing is, see, this time TTL is too far because they are IBGP neighbors, right? So there is no problem related to TTL because we are forming IBGP peering between them, right? But the problem is, you can say debug IP BGP. You will see that it will show you that it does not have any route to reach 22222. The reason is BGP do not trust default route. BGP do not trust default route. Let me show you. See, what is it saying? No route to peer. So you do one thing, say IP route, fine, and configure this command only on one end. It is also not necessary to configure it on both ends. It's not necessary to configure it on both ends. If you configure it only on that end, which is initiating your TCP connection, it will be enough, more than enough. You see, R2 is still having only default route, but this time there will not be any problem. But at least on that end who is initiating your TCP connection, it must have a dedicated route. Not, exact route. Even you could also configure 2.0.0.0/8 as well. Like in place of it, you can remove it now and then say IP route 2.0.0.0 to 5.0.0.0 and next stop is what? Now show IP route, see, and then say clear IP BGP star. Neighborship have came up once again. That is also another rule of BGP. Fine.
second hand से भी हम default route पे डाल तो भी चलेगा.
What?
अगर R2 से default route पे डाल तो भी चलेगा.
नहीं, फिर कैसे reachability कैसे रहेगी R2 से R1 पे?
वो background पे check करता है कि वो reach.
Exactly. Of course. Router, because router is encapsulating your TCP into IP, and then IP is what? IP header. It has to perform lookup in its routing table. Is not it?
तो सिर्फ lookup करेगा default route होगा कर देगा या फिर वो
जब lookup करेगा, then it will not. If it lookups for BGP based packet, then it will not consider your default route. But this time, because it has sent from R1 to R2, now R2 can consider it.
R2 consider करेगा default route.
Exactly. Do show IP route. Now R2 will start to consider this default route. Fine. So in this way, you must remember all these small things of BGP. Fine. Apart from it, now do one thing. Okay, I have already removed this default route from R1. Default route is there, but also I'm having this individual prefix, right? Now let's move back again on R2. Say IP route 255.255.0. Next stop is fine. individual route is there. Say no router BGP 100. In same manner, I will move on R2, R1 as well, and I'll say no router BGP 100. Nothing, no BGP. Fine. Now say router BGP, remote is 200. eBGP neighborship this time, right? eBGP neighborship. Then go to, and I'm not disabling the default address memory, right? That is why neighborship must come up automatically. Sorry, I didn't define update source on R1, right? So I have to say in same manner I'll move on R2 and I'll say remote AS is what? Neighborship must come up, right? So IP BGP somebody. It is stuck in idea state itself. However, this time it is having all routes and all, but still your neighborship is stuck in idea state. Why? TTL. Fine. But the problem is only one TTL is enough, is more than enough. Because your neighbor is directly connected. See, this 222 is who? R2. So TTL1 is enough. Then why is it not forming neighborship? So what? If traffic is going to loop back, will it increment? Will it decrement your TTL value? Never. Never. Remember, your TTL value will be decremented out from your packet whenever it will send that packet out from the interface. But this time this interface is existing on R2 as well. R2 itself. It is not placing it onto any physical media. See, remember, it's true that by default TTL is 1. But this time it is in ideal state. Ideal state means BGP process is not, it's started, but it is not initiating TCP session. So how can we say that, okay, it is not coming up due to TTL value? Even if even TCP is not initializing its session, then how can we say that, okay, neighborship is not coming up due to TTL? At least packet should be occur. Packet should be generated by BGP. At least BGP should initiate your TCP session. But this time you can see the debug IP BGP, even it is not initiating your TCP session here. Even I can say clear IP BGP star. So what is it? It is not initiating TCP session. Has it sent any SYN message over here? Tell me. Even you can also, we are already captured it, right? See, there is no SYN message. They are sending CDP and all these things. Are they sending any SYN message over here? It was previously configured, right? Forget about it. But now they are not sending SYN message. Means that now R1 is not initializing your neighborship, and R2 also. R1 and R2, both of them are not initiating their BGP neighborship. You know why? There is a rule, directly connected stack in BGP. There is a rule of directly connected stack in BGP, but only for eBGP neighbors. But only for eBGP neighbors. According to BGP, by default, eBGP neighbor must be directly connected. That is why by default its TTL value is what? 1. By default, according to the BGP, your eBGP neighbor must be directly connected. This feature is by default enabled in eBGP. If your neighbor is not directly connected, if your eBGP neighbor is not directly connected, in that case BGP is not gonna to initiate your BGP neighborship. Even TCP session 2, if your neighbor is not directly connected, then BGP will not initiate TCP session as well. Have you understood this point or not? So here TTL value will come after the initiating TCP session, right? So in this case, even it is not initializing your TCP session as well. Now to solve this problem, you have two options. Either change your TTL value. If you change your TTL value in BGP, like if you have configured your TTL value as 2 or 3, then your directly connected check rule will be disabled automatically. Remember, for EBGP neighbor, if you change your TTL value, then directly connected check rule will get disabled automatically. But this time I know very well that I don't need to have TTL value higher than 1, because I know my neighbor is just 1 hop away from me. So why will I change my TTL value? So in BGP there is another feature also exists by which you can disable directly connected check feature, directly connected check rule for EBGP neighbors, and the command will be this: router BGP 100 neighbor 2.2.2 disable connected check. Now at least it can initiate your TCPC ideal to active, but still R2 is not doing anything. So you do one thing, move back again on R2, say 1.1.1 disable connected check, so that it can also initiate your TCP session. Have you understood it or not? But this rule of connected check exists only for EBGP neighbors. This directly connected check rule exists only for EBGP neighbors. Understood or not? So see, neighborship have came up. Did you change your TTL value? So will loop back decrement your TTL value? Fine. Yes, in case if you are going to form EBGP peering in between R1 and R3 or R1 and R5, like in between R1 and R5, right? In that case, definitely you will require to change your TTL value. In that case, it will work even if you do not disable this connected check rule, because what I said, if you change your TTL value, then this rule will get disabled automatically. Have you understood it or not? This is, see, still from last half an hour we are playing only with BGP peering only, BGP neighborship. So these types of problem can occur during BGP adjacency formation only. So you must remember all these rules of BGP. Then after it, this time I'll configure indirect neighborship in between R1 and R3. So what can we do? We can enable EICRP or OSPF between them so that their loopbacks will be reachable with each other. Is not it? And before going for that, let me tell you that how can you advertise anything into, networks into BGP, right? So if you want to advertise anything into BGP, like here, do one thing, say on all, show IP BGP summary, fine. Show IP BGP, do you have anything inside its BGP table? No, because you have not advertised anything into BGP. So remember, the uses of network command will be quite different in BGP as compared to IGPs, because in IGPs we were using network command just to enable those routing protocols onto their interfaces, but here in BGP you will be using network command to advertise your prefixes. Actually, let me tell you, interface loopback 10, Remember, in BGP by default auto summarization is what is? Oh my god. Fine. So now auto summary is by default disabled in BGP. See section router BGP. Check it out. Right? So you are not required to disable your auto summarization in BGP. Fine. Now you have 10.1.0/24 connected here, right? Now you went to BGP and then you said 10.1.0.0 mask is 255.255.0.0. See, if you are going to advertise a classless network, then you have to specify your mask. But if you are advertising anything as classful into BGP, then you are not required to specify your mask value. So will it advertise into BGP? Do show into BGP? No, not yet. Because if it was advertised into BGP successfully, then it must have this prefix available inside its local BGP table first of all. And if it is not available inside its on local BGP table, it means how will it be possible to advertise it towards its neighbor? So if you are advertising anything into BGP, you must check your own BGP table first of all. If it is available in your own BGP table, it means it can also advertise it towards its neighbor as well. But this time it is not there. See, there is a rule in BGP that whatever you are advertising with using network command into BGP, that must available inside your local routing table as well. So was that prefix available inside your local routing table? No, it was 10.1.1.0/24 actually. So remove this command from here and in place of it now configure 10.1.1.0 and mask is yes 255.255.255.0 and then check do show IPv6. See, now it is there. So remember, whatever you are advertising into BGP must present in your local routing table. One more thing I can show you here. Remove it. If you have enabled auto summary in BGP, then after let's say that you have hold time. Why hold down timer expired? What is this? Okay, then let's do one thing. I'm gonna to save it and I will start it in next class now, right?
Thank you so much, guys, for watching my video. So we'll be coming back with few more videos of the BGP. Please subscribe my channel. That's @ARC_tutorial. Thank you so much, guys. See you in next video.